Hello, everyone. Hope you all had a really good lunch, and now we are going to get back into it. So right now, we are going to be talking about Harvest, a Threat Labs automated macOS malware tool. Just as a little bit of housekeeping, at the end of the session, when we get to the Q&A, I am going to be running the microphone to anybody who's got a question, specifically so that we can catch your really good question on the recording and the fantastic answer as well. So without further ado, I'd like to bring up to the stage Jaron.
Thank you. Yeah. Hello, everybody, and thank you so much for coming to my talk. A Threat Labs automated macOS malware tool that we've named Harvest. Essentially, the idea here was to, for this JNUC, try to provide a little bit of insight in terms of what Threat Labs is up to. We know there's a bit of a black box sort of feel to what we're doing, and there's a lot we're actually doing behind the scenes to power Jamf Protect and things like that. So we just kind of want to get into some of the projects that we're working on and shed a little light on some of the cool stuff we're doing. And if nothing else, give you at least some insights into a really cool automation project that we've been working on. So. Again, my name is Jaron. I'm the director of the Jamf Threat Labs team, so our goal is to try and find new ways to detect macOS malware on systems, whether that be through behavior detection, static detections, things like that, and ultimately keep our customers safer is our goal, as well as to just shed some light on the threat landscape for macOS in general. So what we're going to talk about today is Harvest, and we're going to kind of do this with a special sort of a demo that we've put together using a info stealer. So if you're not familiar with info stealers, they're kind of all the rage right now. Users are downloading these left and right, and essentially they're applications that are backdoored by a user somewhere, and they're hosted online. For instance, we did a blog post on one for Arc browser. Some hackers had basically put inside of the Arc browser, a macOS browser that's kind of gaining a lot of popularity. Essentially, they put a stealer in a fake version of Arc, and then they went and they bought a sponsored Google ad space that looks like Arc web browser. So when you search for download Arc browser, instead of coming to the legitimate one, you are brought to this sponsored ad by Google, and when you click on it, you are brought to a fake website that is not technically Arc browser. So as you can see kind of at the top, the domain is not Arc, rather it's just something that's a bit gibberish and sort of looks like Arc and probably won't necessarily capture your attention. So this is really popular. It's not just Arc that attackers are going after with this. They're doing all kinds of software, all kinds of different apps. And we've been seeing these. If you take a look at Atomic Stealer, it's been seen left and right by different security companies, including us. So anyway, what happens is you go and you download that. It looks legitimate, but you end up with these specific instructions on how to open the app when you download this version, and that is by right-clicking it and then clicking open. This is to get around gatekeeper checks. As of Sequoia, it doesn't technically work this way. Apple's put a new gatekeeper check sort of in place that requires you go into your settings. You can no longer kind of right-click to get around this. But this is what attackers were doing to get around gatekeeper checks, literally instructing you to bypass gatekeeper. So this has kind of changed, but it's going to be interesting to see how attackers do this moving forward. When you download that, you right-click it and you click open. An info stealer runs essentially instead of the Arc browser. You get no browser in front of you. An info stealer runs. It goes through your entire keychain. It grabs your cookies from your web browsers. It grabs any crypto wallets you generally might have installed. Maybe it looks at multi-factor authentication software that you have installed. It basically grabs anything that it could use to essentially impersonate you from a different computer somewhere, or those credentials that are stolen or sold on the black market somewhere. It's hard to tell exactly what happens with this data after it's taken from your computer. But needless to say, this is why we're using info stealers kind of as our example for a malware sandbox, is because there's very much a use case around it right now that we've been seeing in the wild. So from a harvest perspective, what is harvest? Well, what we will do is we're going to take this executable, all right? So we have a lot of interest in macOS executables, and that's what harvest is looking at. It's specifically interested in not necessarily the full app bundle at the moment, but the specific executable that is within that app bundle or standalone executables. Because there's a lot of information that you can get, both static and behavioral, from a standalone executable. So we will take that executable that in this case might be an info stealer, and this is kind of how harvest works now. That first we can go to a web interface and we can upload the executable we're interested in. We can do the same thing with any malware or any goodware. It doesn't have to necessarily be we think this is malware. We just want to report on a specific executable. So we'll upload that through a web interface, and that sample is then sent to our backend. And once it hits the backend, a copy of it is made, so that we'll always have that sample moving forward to reference. We save that off, and ultimately we kind of just get this giant database full of executables, hence kind of the name harvest, right? So what happens then is we actually have what we call a Mac mini farm, essentially somewhere around 10 Mac minis that are all running kind of in unison in our server. And essentially those metal Mac minis, those actual Mac minis that are running, can see the fact that a new sample hit our database and works on a first come, first served basis. One of those Mac minis is going to try and grab the sample. Once it does, the others will just go into waiting for another sample to be submitted. So with 10 Mac minis running, gives us a lot of flexibility in terms of how frequently we can do this and how fast we can actually accomplish this. So starting once it gets onto that Mac mini, the first thing we're going to do is perform some static analysis, right? This is analysis where you don't have to detonate the malware. We can just, or the executable, we can just look at the stats about it. We can pull different information. We can compare it to other executables that we have. Basically, any type of automated analysis that we might do as malware analysts, we can have that all just kind of done for us and give us a report by the end of that. So static analysis comes first, and this can be anything from Yara scans to checking the strings to checking what libraries are in it. I'll give some examples of this once we get into what a report kind of looks like. After that, we do behavioral analysis. So this is actually one of my favorite parts because it is actually rather complicated in terms of what we were able to set up. So we use the Apple Virtualization framework, which is going to spin up a virtual environment on the fly, and it's going to move that executable into that virtual environment. We've done this all manually, all programmatically, which essentially allows us to load in the executable, run it, detonate it, see what it does, and then tear down that virtual environment as though it never existed. So what's cool kind of about an environment like this is we're not battling the user. It's a very controlled environment. We know what software is running inside of this environment. So like what the malware does or what the executable does, it's actually very easy to pick out from what's running on the system because it's a very controlled environment. So that also helps a lot. So once that finishes running, all of that information gets compiled into a single report. We take that report, we grab some of the interesting stuff from it, and we add kind of our own flavoring to it, right? We have a lot of intel already available from the Jamf Threat Labs perspective, so we'll take the hashes, we'll check, hey, did we already know about this? Do I already know if this is malicious or benign? Because if we do, then we don't really have to read this full report. We can already declare it's malicious and we can kind of move on, right? So we add a little bit of just our own knowledge into automated knowledge into that executable report, and then that report then gets stored off back into our cloud where we can reference it by hash at any point. So anytime we run into a hash out there in the wild, or anytime we have a question about, okay, here's an executable, I don't know really anything about it, we can go and hope that we've run this executable through Harvest before, which will give us a full report of what happened. So this is kind of your initial sort of Harvest screen once you're looking at a report. So once you've searched a hash, you're kind of brought here. Here's your high-level submission details, right? You have your hashes, which are fingerprints for files. So like we know one-to-one, where if we have a certain file in question, we can find it exactly like it is by searching the hash. You get a history of, okay, like we submitted this to Harvest on XYZ date. Just helps us do some timeline around threat intelligence, stuff like that. Now, if you look here kind of under it, there's another thing I wanted to note, because this is sort of relevant, and that's the fact that we are performing analysis on 2 different executables, right? So if you've been following kind of the big switch from Intel to the M1 chip, you would know that within every executable, what we actually have is 2 executables. In most cases, we have, for instance, here is me looking at the whoami executable that's on my system. I see that within that one executable are 2. There's a whoami for Intel, and there's a whoami for ARM. And this ensures that no matter what laptop you have, your macOS edition can take the file that you've loaded to run, it can grab the right architecture for your system, and it can load that, because otherwise it won't correctly execute depending on the architecture you're running, right? And you can actually do this with up to 6 executables embedded inside your one universal binary. This is also the reason your operating system is technically twice the size of what it needs to be right now, because it has to support both Intel and ARM. But to do that, Apple just mashes these 2 executables into one. Now, the fun kind of point about that is you, in theory, could take 2 executables and combine them into one executable, leaving one completely benign executable and another malicious. Like if I know I'm only targeting ARM laptops, for example, technically, I could merge my malicious ARM executable with a non-malicious Intel executable. It'd be a really strange thing to do, but you could do it. For that reason, we have to make sure we're analyzing both. It's just kind of a small detail that is relevant, and I pointed out. So when we take that sample, we do analyze both. So after that, and we'll just stay on the x86 one at the moment, but we have a Mach-O header. So for every executable you have Mach-O details. There's specific flags in that Mach-O detail that might provide you some information that's interesting. We're going to skip over a lot of this because it's low-level, really nitpicky data that comes in handy in very specific scenarios that we won't really be dealing with here. But we get the Mach-O header information and kind of parse it out manually. All the parsing of this Mach-O executable is being done programmatically with custom code. Next, we have the signing info. What you'll notice here is this sample is signed by me. That's not normal for info stealers. Most info stealers are not signed at all. This is signed by me because it was part of a demo, and we wanted to showcase that, hey, like when we parse this Mach-O executable, we pull the signing info out and provide all the different signing info that we can. This is relevant because in the world of threat prevention, we would take this information. For example, we would find out eventually that this executable is malicious, and then we would take this signing info and we would block this developer moving forward if we ever saw it. It's an aggressive sort of policy, but it's one that we enforce, and it's treated us pretty well throughout time. So if my team discovered that this executable was malicious, my Apple signing certificate would now be blocked, and anything that I write moving forward would no longer work if we're running, Jamf Protect. So, but just for demonstration use cases here, it's not actually malicious. Please don't block me. So after that, we have the libraries. Libraries are great indicators of what functionality a Mach-O executable might have. So we grab these and print them out. First are the standard libraries, which are kind of statically embedded inside of the executable. In other words, functionality that it's merged into the executable itself, sort of. And we can notice by looking at those, we got a rough idea that this program, this executable, is probably written in Swift, just based on the libraries that are within it. Below that are the weak libraries. Sorry, that's the normal libraries. Below that are the weak libraries these are also called kind of dynamic libraries. And we see kind of more signs that this might be written in Swift, as well as a couple other, core libraries. We don't see anything that leaps out here as like custom built. It's just good to know what's being imported, because sometimes you find a little nugget that's being imported that is super helpful and might be like, hey, what is that? That's not a standard library. That's pretty interesting. Many executables, when you compile them using Xcode and give you a UUID as well, that's towards the top of the executable. Not really using this actively, but in theory, you could build out a UUID, a database of UUIDs that might match certain executables to certain versions of those executables. But that hasn't overly been explored almost by anybody at the moment. So that's kind of the standard executable data that we collect from a static perspective. There's more static stuff that we do, but we'll get to that in a second. That's really just basic information about a macOS executable. Next, we have the runtime. This is more my favorite part, right? I told you that we boot up that virtual environment, detonate the malware in the virtual environment, and we capture everything it's doing as it runs. So this is what happens during runtime. So the first is we're able to look at endpoint security events that were generated when that executable was run. So inside that virtual environment, we're kind of just capturing nonstop what's happening using a custom-built endpoint security extension. And the first thing that we can see is that one of our detections for behaviors went off that says credential theft. And the detection name is AppleScript prompts for credentials. This is something that we can kind of detect automatically by simply looking for someone running AppleScript with the word password in it or something similar to that, right? And this is what info stealers do to get your password before they decrypt your whole keychain and ship it off somewhere. They throw a prompt to the user saying, I need administrative rights to install, because you think you're installing a real app. You plug in your password, and that goes right back to the attacker in plain text. So kind of playing off the attackers, instead of going for the very complex dump the hash, crack the password, spend time trying to brute force it, simply ask for the password, and it has been wildly successful. So we see that AppleScript ran, and it asked for somebody's password using a one-liner command. This is what almost all info stealers are doing. We see there's a KC password reveal. Info stealers aren't doing this. I use this more to showcase something in this demo. Is just another detection we can look for credential theft, and that is there's a very popular command you can run, a one-liner command with Ruby, where if the user has automatic login installed, technically your admin password is stored in a file called etc password, nearly in plain text. It's encoded with an XOR key. If you go through you go through each line in that file with a hard-coded XOR key, which you see there, kind of in that array. You can go through each character, and you can just decode it to get the user's plain text password in less than half a second. Don't use automatic login for that reason. Now, there are some other caveats with that, where you kind of have to gain root permissions to access it, but there's still very bad practice on that front, especially because it saves your password. Very easy to crack. The other thing I would note on that front is if just because an attacker already has root doesn't mean they won't try to figure your password out. Your password's very valuable in terms of lateral movement. Maybe I'm going to look in your SSH keys, look in your recent SSH hosts, try and find out where you log in. If I have your password, I can do that. If I don't have your password, I might not be able to do that. We see there's another credential theft detection that's called Safari Cookie Open. And that's essentially what it sounds like. We're looking at open events, watching file open events, and seeing who's opening see what programs are opening different files. In this case, I see the program itself, which we name sample, running on the user's desktop. That's kind of our detonation path that essentially we sort of double-click through automation. I see that's what accessed the Safari cookies, which is pretty strange. Programs, specifically Safari, is probably going to open that cookie file, but There shouldn't be too many other things that are doing it on a regular basis. Certainly nothing that should be doing it in like a 5-second basis from when we detonated this malware to when we tore down the machine, right? Another credential theft is the security commands. The security command can kind of be used to manage your keychain from the command line. Maybe even use this in some type of automation in some of your Jamf scripts or anything like that. But this one is the unlock keychain -p. And then you can do that if you're kind of logged in as a user. I can't remember if you have to provide a password after that or not. But regardless, most info stealers run this command. So it's just kind of like, we're gonna watch for when this command is ran, because there's not a ton of other reasons to do it, even though some maybe password management third-party software might also play into that command as well. We have a process exit. That's exactly what it sounds like. The process ran and it exited at some point. We will actually, if you run a program inside of Harvest, we'll let it run for about 3 minutes before we tear it down if that program doesn't exit. So if the program exits, we'll tear it down immediately, which means you can detonate a sample in like 5 seconds from submission to the UI all the way to having a report. You can get that back sometimes in nearly 5 seconds. But if the program is a longer running service, for instance, maybe what detonated was a backdoor service, that we would allow that to stay open for 3 minutes. Who knows, maybe an attacker will send some commands from a C2 server. We would capture those. We'll let it run for 3 minutes at max before we tear it down. So that process exit is just kind of telling us, hey, this process exited at some point, and that's why we tore Harvest down. There's another one, kill all terminal. This is a very popular command that info stealers have been using, and the reason for that is usually because they will detonate by opening in terminal. You double click it. If you're crafty enough, you can get your double click to open in the terminal. You can run it, you can background the task really quick, and then you can run the kill all terminal command, and that will hopefully for the attacker hide the terminal before the user even sees that it popped up. You ever like run something and you see like a terminal window pop up and it disappears and you like freak out for a second? That's happening because of this command. So the kill all terminal, it's very little reason to run that unless A, your terminal's hung, or B, you're trying to hide the terminal. And there's a couple different ways to do that, but this is sort of the example we kind of leaned into. Oops. MD-find search. So on your system is Spotlight. If you use Spotlight, command in space, right? I use it all the time. It's super helpful. Helps me find stuff that I would never find otherwise that I have buried in files somewhere, right? And you can search a keyword, and that keyword will show you any files on your system that have that keyword in it. Useful for users, also very useful for attackers. I can punch in the word confidential, and I can see every confidential document you have within a matter of half a second versus having to go through every file and search for it, right? So in this case, just noting that the mdfind command was run, that's going to be really strange. If we see the program that we submitted to this sandbox running the mdfind command, I'm going to be really interested in that. Info stealers are starting to catch on to this as well. It's how they find the most interesting documents on your system and decide what to send to their C2 server. Terminal kill, we already kind of saw this, but this is us picking it up using the ES signal event rather than trying to find the attacker running the command. So if malware terminates the terminal using a signal call programmatically instead of like calling the kill all command, we'll still catch it. And I'm going to skip through some of these a little bit quicker. Curl creating a file. Attackers download stuff all the time with curl. It's how they send further payloads to the system. It's also, you know, what a lot of admins sometimes use to get files to a system. So you can't assume just because curl runs that it was malicious, but it's certainly going to be notable in our sandbox. And what it's downloading there is actually Chainbreaker, cb.zip. That is a way to basically provide, you can provide that tool. It's on GitHub. It claims forensic purposes for your keychain, but in reality, it allows you to extract like a master hash for the keychain and allows you to do some auto exportation of keychain details if you know the password. So a lot of info stealers have been downloading that as a stage 2 and using that to exfil your keychain. Don't worry too much about file and downloads. That's actually a cached file that got picked up while the sandbox was running. Files being created in the temporary directory is something that we care about a fair bit. That temp directory is used nonstop from an attacker perspective. Attackers love this directory. It comes with the whole Unix background of being world writable, world readable. So if you want to save malware to a location that you're guaranteed to have permission to write to, unless maybe you're sandboxed, that temporary directory is constantly used by attackers. Also used by legitimate software. You can't assume because it's in the temp, it's malicious, right? And then the fact that a file was created and shared, we actually see this is once again, it's that cb.zip was both created by curl and it was written to the shared directory. This detection would exist for different purposes. We actually see the DPRK, a lot of malware coming out of the DPRK, writing to that user's shared directory where nobody else stores data. Nothing should really be in there. macOS users don't even really know it exists, but a lot of very advanced malware will use that directory because it's also world writable, world readable. So that's kind of a long-winded sort of rundown of the behavioral portion and what we're looking at in terms of detections. And we can kind of modify any ES event we have to benefit us from a detection perspective in the sandbox environment, which is really powerful. That's just a little bit of what we're capable of doing there. During the runtime, we also capture like the event counts for the different events that occurred. So those are all ES events that you see on the screen, and we're just kind of documenting how frequently they occurred. We're not doing a ton with this just yet, but maybe somewhere in the future. Process info of the malware when it ran. We capture that and we report all that just so we have it for our own reference and we can kind of correlate it inside the report should we need it. And then all the different files that were opened, renamed, created, those all get documented here. Maybe we find something interesting, maybe we don't. It's sort of a toss-up. We're working on formatting these a little better to have kind of better documentation of what actually occurred when it occurred. Right now it's just a big list of files saying these files were involved as the malware detonated, and that can often lead to, if you don't know you're dealing with an info stealer, by looking at some of the different files that are being accessed, sometimes you can sort of get an idea of maybe what you are dealing with. During the runtime, as we detonated the malware, not only are we capturing the events that are occurring on the system, we're also doing a TCP capture so that we can monitor the traffic as the malware detonates. So we see there that there was a connection that was outgoing to a 162 address. This is actually to my website. Again, this was to showcase an example here, not to actually show malware, but show what malware generally does. So this is actually my website, themitandmac.com, that it reaches out to, and we see there's one outgoing connection. Now, if we want to verify that or we want to look at some of the manual traffic, while we're doing that TCP capture, we're obviously going to save that file so that when the malware detonated, we have a file to reference if we want to go look at all the network data. So we would do that with Wireshark, presumably, or your favorite PCAP tool. But we're going to load that in Wireshark, and we can kind of go in and take a look and find themitandmac.com was indeed reached out to, which you can see there in the hex if you look close. But anyway, it's just another option for another location that we can go to get extra details about what happened on the system, should we really want the low-level details. And this is obviously in attempts and in hopes to, if this truly is malware that we're detonating, we're going to capture some type of attacker C2. We've, of course, seen malware that requires, the malware isn't truly malicious until you take a PDF file and drop that PDF, which holds all the attacker information. We've seen all kinds of stuff, and there are times where you detonate the malware. You might not necessarily get a C2 back, but we definitely want to ensure, if we know we're dealing with malware, and we grab the attacker command and control domain, like now we can block this if we know it's malware, like keep everybody safe. So that is kind of the network side of things that we're just doing in advance. And we have some ability to then go perform checks on these IPs as well to determine if they've been seen as malicious or not in the past. Screen recording, we're going to record the screen kind of as we detonate the malware. 9 times out of 10, you're not going to find anything interesting here. There's going to be almost nothing because malware doesn't generally like to do stuff in front of you, right? It's generally a behind-the-scenes type thing, unless there's like a social engineering aspect sort of involved, which for us, when we detonate the malware, we, of course, I mean, that's a demonstration terminal popping up there, but the malware does prompt, and this is what it looks like when Atomic Stealer will prompt you. You get a little prompt that looks just like this, and it asks for your password. Yes, over the course of macOS, like this is what stupid little prompts have looked like that come from the legitimate side of the operating system as well, which is why this continues to work on users, is because it seems legit. Now, macOS doesn't really prompt like this anymore, and we're trying to message that out, where like you shouldn't see prompts like this. If you see a prompt like this, it is almost guaranteed to be someone trying to take your password, or it's an admin script that is maybe a little bit thrown together and maybe not best practice. So in there we got a bit of a capture, but a lot of times we would expect this capture to be sort of empty. Code features, we have the ability, I kind of mentioned earlier, to sort of look in the strings. Nothing here overly interesting in the Swift strings, at least not in that. But in the C strings, which Swift, if you're familiar, will store different strings as C strings. We can parse those out separately, and we actually do all the demangling of Swift strings as well. So we get fairly involved in strings, and that's because with malware, sometimes the easiest way to spot malware and analyze malware is to just simply look at the strings. You'll actually notice in this that I can nearly tell exactly everything this program is doing by looking at the strings, and that's because every attacker command is saved as a variable that is just a standard string. So this is actually something we always look at is the strings, and it only makes sense to make sure that we're parsing those and saving those out separately. Next is the static analysis. So by static analysis, you know, we've kind of been doing that this whole time, but with static analysis, this is kind of our tab for saving off like YAR rules that we run against the executable that are a little more experimental. If you're familiar with Yara, you would know that you can go create a rule that says, look for these strings inside this file. If you see them all, then this is this malware. It's a very static kind of antivirus way to detect on malware. And we have a number of rules that we use in Jamf Protect, as well as a number of experimental rules that we can kind of use here in Harvest, where here you see three different hits occurred on this particular file, and that is first off an embedded file extension. So if a program has, you know, .doc, .xls, .docx, if it has a big list of programs, that doesn't make it malicious, but that's notable. That means that this program is probably going to go and it's going to look for a bunch of different files on my operating system that exist on my disk. And we want to know when that's a thing. Again, it's not malicious, but it's just good information for us to have where we don't have to go in and figure that out manually ourselves. Next is crypto wallet browser extension IDs. This is a YAR rule that looks for like 10 or more Chrome extensions. When you have a Chrome extension, you have a unique, like, kind of serial looking identifier. And if you take 10 different of those extensions and you put them in the same rule and say trigger anytime you find a program looking for 10 extensions, that's pretty notable, right? It tells us that this program is probably trying to see if there's any crypto installed on this system or the user has any type of wallet on this system. And then finally, embedded MFA browser extension. So we're looking for multi-factor extension IDs as well. That's kind of the same concept. Any program that's basically doing a check to see if you have multi-factor software on your system, that's also pretty relevant. Doesn't make it malicious, just makes it notable. And then finally, we have a tab for Jamf analysis, and this is actually for a different piece of malware. I changed the screen here. This is for something that we call Thief Bucket, which is a recent blog post that we put out on some DPRK malware. But the Jamf analysis is basically going to take this submitted sample, and it's going to run it through our known database and tell us, hey, like, have you seen this already? Do you know if this is malicious? Because like, there's no point in letting that intel go to waste if we have it right on hand, right? So in this case, it'll come back true and it'll say, yes, this is malicious, so like don't bother looking further into this unless there's extra details from it that you need, because we already know about it. So super handy tab where we're able to check that out. And that's kind of an abrupt conclusion as a walkthrough of Harvest. Again, this is a tool that we're trying to open up a bit, just about some of the automation that we've done and some of the cool projects that we're working on, so you can have some visibility into the Threat Labs side of things. So yeah, thanks for joining the talk, and yeah, thank you.
Thank you very much as well. If anybody has any questions, go ahead, raise a hand aloft. I will come to you, and all of a sudden, let's go.
So one of the last things you just mentioned was that you had just published some blogs. Is there a list of feeds that we can get that you'd advise us to follow for that type of thing?
Yeah, in terms of the Jamf blog side of things, the Threat Labs blog, which you can find right from our main page, or if you Google and just put Jamf Threat Labs, it'll bring you right to like the home page, and you can kind of track that for the different research that we're releasing as we do it. So on the macOS side, we try to release any interesting finding that we have, so long as we're able to, and then that also gives you anything that the like the iOS mobile team is working on, as well as kind of like the network side of things too. So.
Okay, and then I have a second question, if that's okay. If a reputation of a signing ID improves, how do you go about clearing that?
So currently our policy is kind of like, if it's bad permanently. Apple actually has a very similar policy, but they're a little more lenient on things like you might see adware get packaged with a program. Sometimes they might not block those specific adware items, as we're a lot more strict on that. If somebody comes to us manually, like to maybe Jamf support or something like that, and they say, hey, I'm trying to run this software, it's legitimate, or I purchased it, and it maybe has a questionable reputation versus a malicious reputation, we will go look at that. We will take the time to go look at that and say, hey, we're either going to lift this because you're right, like we have some question marks about this, but it does appear to be legitimate, and we can lift that and allow it to run. So it's kind of on a as-needed basis that we sort of treat that. Yeah. Yeah.
Would it make more sense to use password managers such as 1Password instead of relying on the keychain?
So that's a great question, actually. Not one that I particularly know the ins and outs of. Attackers do also, in those info stealers, they will look for password management outside of the keychain. I will say that pulling that data is probably more complex than getting out of the keychain. Apple has sort of this, like, yes, the keychain is really convenient, but it does have some flaws in that you type in your password once, like accidentally, to the wrong thing and your stuff's gone. I would imagine with 1Password and stuff like that, there probably are arguments where it's a little more complicated to get that data out versus the built-in commands that are available on macOS. So potentially yes, but I wouldn't know the logistics of how difficult that is to do from a different perspective of password. Yeah.
Hi, amazing stuff, by the way. I'm interested to know if there's any plans to make Harvest available for partners and potentially protect users in the future. Because the way I look at it now, this looks like something very similar to how VirusTotal kind of works, where it's a conglomeration of data. So I think it'd be helpful for like the security industry to kind of have a little bit of help in making that database even larger for you.
Yeah, great question, and one I was waiting for, actually. I can't speak exactly to future plans with it, but I can certainly note that we have noted those opportunities as well. So although it's TBD on exactly where we're going with it, there's many different use cases, like you just mentioned, where we realize that technology like this wouldn't just benefit our team, assuming it was more available. So yeah.
Will the data start to show up in Protect? So, you're showing all of this that you're getting as we're seeing these things come through. we just went through a POC with CrowdStrike, and they're showing screen recordings of what they're blowing up in their sandbox and that sort of stuff in their tooling. Will this features, I get you can't completely say what the roadmap is, but is there, ideas of doing this?
Those are the ideas we've noted. Yeah, again, I'm not a product guy. I can't mention to where this fits into that full picture, but those are definitely the things that we've noted. There's other, complexities around like, all right, we're not, like some of these other vendors might be doing some automated collection of certain things running on your systems. That's kind of a privacy offhand stuff for us, right? We're not going to pull data off of your systems to submit them to our sandbox, right? So that would have to be, more of a some type of design where there's a place to submit it rather than like auto extraction. That's ours now, So, but yes, definitely noted. Yeah.
Is there any idea when this is going to be released? And like I know you said that it can't speak to it yet, but is it going to be behind like a paywall for Jamf Protect, or is it going to be something that's open source for the community, kind of like VirusTotal?
Yeah, that's we can talk a bit after and whatnot if you want, but yeah, I still regardless don't have specifics into that. We were pushing actually really hard just to kind of get everything up and running by the time we hit this. So this has kind of been the focus, is just to be able to display it and kind of see, hey, like any interest in this, but any interest you have goes a long way for sure if you want to talk after or anything. Yeah. Yep. Got one way in the back. Good? All right.
Okay, unless I have missed anybody, it appears that we are out of questions. If anybody has any questions for you later on, how can they find you?
Yeah, I will be outside after this for just a few minutes. I'm down to talk about that. Yeah, and also, I mean, if you're on Mac Admins, you can find my name on there as well. If you want to chat or anything about that, or a question clicks to you, a couple days from now or whatever it be. So, but I'll be in the area for the next 10, 20 minutes. So.
Excellent. Thank you again, and thank you everybody for attending.
Cool. Thank you.